Okay, physical science students, last video of the year, but it's a pretty important one. I'm also going to post after this video, which is going to be called Practice for Test 2. You should rewatch Practice for Test 1, and you could rewatch isotopes or any of those to prepare for the test. Remember that your test tomorrow, how you're going to do that test is in today's document. So make sure that you look at that. Most important thing is, if you don't email me at your assigned time to take this test, I'm not going to email you the link. I need to know that you're there because you only have 1 hour to take it. So here is our last video. I want you to be able to interpret Bohr models, which is what our last test practice video was on, where I would draw a Bohr model. Let's just do a really, really simple one. If this type of thing is still confusing you, go back and rewatch the video on test practice, I think it was called. I'll repost it. So what I'm doing here, this Bohr model, is I'm representing the nucleus of an atom. And then outside the nucleus, remember, I think I didn't do this with you guys. I just put big dashes. Typically what I do is I put an E and a dash to represent an electron, but I'll stay consistent. Let's just go ahead and do this. All right. So then I would ask you questions about this. Who is this atom? What is this element? You would look at its number of protons, the plus is protons, and you'd say, oh, well, that's lithium. And then you would say, it's lithium that happens to have 4 neutrons. So this would be lithium 7. When you add the protons and neutrons, that gives you this number that we call the mass number. The mass number is always written to the upper left. You can also write the atomic number here. I never do this like this on a test because I can't put 2 numbers in the same vertical space. And plus it's kind of redundant. If you know that it's lithium because of the symbol, you know it's the 3. And then up here is where we would put the charge. What do we have to compare to determine the charge? We need to compare the number of protons that have a positive charge and the number of electrons that have a negative charge. So if we stretch out the protons and then start assigning each proton an electron, we find out they have the same number. So that's why I didn't write anything here, or I won't write anything there, because there's no charge. It's neutral. That proton is canceled out by that electron, that proton's canceled out by that one, and so on. So that's what we did before. Hopefully you can interpret Bohr models, because we do have some of these on the test. The next thing I want you to be able to do is I want you to be able to take these representations that I'm doing, and I want you to be able to interpret these. So in this case, let's go ahead and practice. Could you tell me the atomic number from what I've represented? Could you tell me the mass number? Could you tell me the number of neutrons? Can you tell me the number of protons? Can you tell me the number of electrons? And can you tell me its charge? If you have no clue what I'm talking about, just keep the tape rolling and get the answers. If you want to try it yourself first, pause the video. Here are the answers. Atomic number. I can't tell the atomic number from this, but I can use this little guy. And I can find potassium. He is over on the left-hand side. He's the 4th member down in the alkali metals. Let me show you this. He's the 4th one down, 1, 2, 3, 4, but he's actually the 3rd alkali metal because hydrogen's just there because of his lone valence electron. He's not a metal. So anyway, potassium. We find out that potassium has an atomic number of 19. We just got that from the periodic table. That's not cheating. That's using your resources. The mass number I have to give you the mass number. You can't get the mass number from the periodic table. Let me show you this. Hopefully you guys can read this. This number is not the mass number. Remember, that is the average of all the mass numbers of all the isotopes found in nature multiplied by their relative abundance. Remember, we did that 40% of this isotope, 20% of that isotope. I believe it's in the isotopes video if you want to rewatch that. But don't just take this number and round it to the nearest whole number and assume that that is the same thing. It is not. You have to be told what this is. I am telling you that this particular isotope of potassium has 40 protons and neutrons. If 19 of them are protons, because that's what its atomic number is, then 21 have to be neutrons. Our mass number is 40. Again, this is something you have to be told, not found on the periodic table. Atomic number and number of protons, el mismo. It's always the same. Number of electrons, okay. There's no Bohr model, you can't count them, but since there's no charge here, we have to have the same number of electrons as what? As protons. Because we're going to have each proton, if we were to stretch them out here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Each one of these has to be canceled out by an electron in order for the whole atom to be neutral. So if I have 19 protons, I have to have 19 electrons, which makes the charge 0. Nothing written there means neutral. You don't put a 0 to tell you it's neutral. Nothing means neutral. Let's do another one. Let's do a halogen. Let's give him a charge, and let me see. I'm telling you, these numbers are littler and littler, and I can't exactly. It's really bad that I can't see that. I think it's this. It should be somewhere close to the average one, but I can't see it. I'm blind. Anyways, so let's just go with this. So let's answer these same questions. All right. Atomic number. I'm just going to erase this so I don't have to rewrite it, because I'm just a little bit lazy. I hiked Table Rock yesterday. Let me just give you guys a little advice. Someday when you're old and fat, such as myself, it's not the best idea to hike Table Rock. I mean, you can hike Table Rock when you're old and fat. You can. But you don't want to hike it with two young, skinny people when they're setting the pace. I nearly died. I'm super sore. Anyway, let's answer the same questions about this guy. So, iodine. He's a halogen. I really, really hope that that number is close. It is. I can see it now. So iodine being iodine, it has to have an atomic number of 53. Again, I got that from the periodic table. Once I find the atomic number, I can immediately fill in the number of protons. Mass number, got to tell you the mass number. Somebody has to tell you the mass number. You can't round the atomic mass to the whole number and think that that's what we're talking about. Sorry, I had to get a drink of coffee. Number of neutrons, all right? Number of neutrons. If we take that number, 128, subtract from it 53, the number of protons, we're going to end up with 75 neutrons. This number plus this number should always equal that number. Number of electrons. All right, let's look at it. First of all, if you think I'm going to stretch out 53 protons, you are not thinking straight this morning. But if I did stretch out 53 of these, let's say that this is the 52nd one. Let's just say that I did. The other one's continue up here. All right, 52, so this would be 53. All right. In order for me to have a -1 charge, I have to have not 53 electrons, I have to have an extra electron, which would make it 54, and then its charge is -1. You will find in some places when you get into chemistry, sometimes I'll write it 1 minus. Sometimes they'll just do this. If there's just a charge with no number, assume it to be 1. I will be pretty consistent doing it this way, but you may see it in other publications a little different. Let's practice another one. Let's go to calcium. So I'm going to talk about calcium. He's an alkaline earth. And if there's anybody that knows the naturally occurring isotopes of these, 41 might not be a naturally occurring isotope. I don't know. I'm just getting something close to the atomic mass, which is the average of all the isotopes, assuming there's probably one. But for example, I think I told you this before, copper has its atomic mass averages 63.4 or something like that, around the 64. But there isn't an isotope of carbon 64. There's only 63 and 65. Anyway, so from this, what can we determine using our brains, our periodic table, and perhaps a calculator? All right. Well, calcium. Standard questions I'm going to ask. And on the test, I don't ask all of these on the test. I ask a few. So make sure you read it very, very carefully. So first thing we'd probably want to know is the atomic number, and then mass number, number of protons, number of neutrons. I think I flipped that from the last time, doesn't matter. Number of electrons, charge. All right. So try to figure this out. Pause the video. Come back for the answers. Answers are here. Atomic number for calcium when we look it up. Periodic table. He's right over there. It's 20. Same as the number of protons. Mass number, I told you the mass number. It's 41. Remember that mass number by definition is protons and neutrons added up. So if I have 41 protons and neutrons, 20 are protons, the other 21 have to be neutrons. Number of electrons. It's a little bit trickier. First of all, let's skip that. Let's just go right to the charge. I told you it was +2. That means that it has to have 2 more protons than electrons. I am going to stretch these out because I think this is important. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Does all that fit on the thing? Yep. All right. So I'm going to I'm going to cancel out every proton. Let's do this. Let's just make it neutral. That would be neutral, okay? Now we have a couple options here. To give it a +2, what if we just added 2 protons? Could we do that? No, we can't. Because if we did that, we would no longer have calcium. We would have, look it up on the periodic table, titanium. Titanium is the one that has an atomic number of 22. You can't do that. You can't mess with the protons. That's illegal, all right? You can take electrons away or add electrons. Electrons are easy to move. You guys move electrons all the time. Ever walk across the floor, dragging your feet and your socks on carpet? You're removing electrons when you touch that doorknob and zzz, you kind of get that little zap of electricity. It's because you took electrons. You can move them. I can move electrons with a balloon. If I had a balloon in my hand and I rubbed it on your head and your hair stands up, that's because I'm removing electrons, moving them around. They're easy to do. So what I have to do is I have to take 2 electrons away to give me this plus charge. So my number of electrons is going to be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 gives me my plus 2. I have 2 extra protons, plus 2. That's how you do this. I'm going to give you guys one more of each. Let's try it. Oh, let's see. Okay, there's a Bohr model of some little critter. I want you to tell me its atomic number, its mass number. I want you to tell me the number of protons, number of neutrons, number of electrons, and its charge. Do that. Pause the video if you have to. Or you can start working on that while I draw something else. I want to draw, this is a separate one. All right, second one. Pause the video, do both of these, come back for the answers. Here are the answers. Atomic number of this one, same as the number of protons, 16. Go to your periodic table, find out that is sulfur. Make a note of that. Its mass number, if you add these two together, it's kind of hard to tell what that was. I apologize. So 16. That gives it a mass number of 32. Number of neutrons, 16. Number of neutrons plus number of protons should always equal mass number. That, let's do it down here. Let's just convert it into one of these. Number of electrons. All right, it's easy. You count them. 2, 4, 6, 8, 10, 12, 14, 16, 18. My hand is falling asleep. That's why I'm holding my pencil funny. So with its number of electrons, we can stretch them all out if you want to. But I've got 18 electrons and I have 16 protons. The difference is 2. What do I have more of? I have 2 electrons. So 2 minus 2 would be my charge. Again, when you're just starting out, stretch them out like I do on those, where I take all the protons and stretch them out in a line. Now let me just tell you, what he did was he stole 2. All right, let me take him, let's make him neutral to begin with. Let's erase those ones that he stole. All right, that's erased. Remember when I said that the outside shell is happy or stable? They're stable when they have 8 valence. Okay, it's a little bit more complicated than that, but for the ones I'm going to give you, just know that 8 is the magic number. As a neutral critter, this is when he's neutral, right? 16, 2, 4, 6, 8, 10, 12, 14, 15, 16. The reason I stretch them out like this is a thing called Hund's rule you'll learn in chemistry. Anyway, that's not 8. So he steals some. So he finds somebody that will give him 2. Remember when calcium had a positive 2 charge, calcium gave 2 away? I bet you he would take them. So that's, this would be a stable isotope of sulfur. So our charge here would be -2. Let's go back down to this one. You're going to have to either interpret Bohr models or interpret these representations. Interpreting this representation, nitrogen is nitrogen because if you look on the periodic table, is one of those main group nonmetals up there, the CNOPs, has an atomic number of 7, same as the number of protons. Its mass number, I told you its mass number. Number of neutrons, 13 minus 7 is how many? 6 neutrons, right? Electrons, there is no charge here. If there's no charge, number of protons, number of electrons are going to be the same. Charge is 0, or you could put neutral. Those are the types of things you're going to have to do on the test, which is tomorrow for 2nd and 4th period. And it's Wednesday for 7th and 8th period. Super excited to be done with this COVID high school. And I will see you guys on the other side.